This video is going to be part of a two-part series where in this one we're going to be graphing exponential functions, and in the second we'll be graphing logarithmic functions. This is specifically geared for people who are not going to be in class on the day we're going over this, but if you would like to watch this to review or maybe start and get ahead, that is perfectly fine as well. So we're going to be applying our transformation rules like we did in previous units. And just as a general form, I'm going to write down an exponential equation of y is equal to a times b to the power of x minus h plus k. Again, that looks very similar to what we've done before. And let's go ahead and get started with applying these rules here. First thing that we're going to want to point out is our asymptote. And our asymptote is going to be the same as what our vertical transformation is going to be. So my vertical shift here is plus 7. So it's going to be going up 7. And so that means I will be having an asymptote at y is equal to 7. I'm going to go ahead and just put that on my graph now just to get that out of the way. So 10, 9, 8, 7, it would be right here. All right, let's go ahead and knock out the rest of my transformations. I notice I have a minus 8 over here, and so that means I will be having a horizontal shift right 8. Remember, it's minus will be to the right, plus will be to the left. And then the last thing I want to identify is this negative sign here in front of my base of 4. This is going to be a reflection over the x-axis. So now that I have those pointed out, I'm going to go ahead and write those under my transformations on my column on the right. So again, we have a reflection over the x-axis. We have a horizontal shift right 8. And then we have vertical shift up 7, which we already discussed. Now we're going to go ahead and get some points that we're going to be using to plot. And we're going to be using our 4 to the power of x as our reference here when making this table. And then after that, we're going to be applying our transformations that we had. So let's use the x values of negative 1, 0, 1, and 2. And then I'm going to go ahead and plug those in. So negative 1 to the power, or 4 to the power of negative 1 would give me 1 over 4. Then that would give me, not 4, 1. This would give me 4, and then this would give me 16 because 4 to the power 2 is 16. So again, we're just taking these x values, plugging them into 4 to the power of x. So we're going to now use these values in this table here. And I'm going to rewrite my x values here of negative 1, 0, 1, and 2 on the far left side of my table. And I'm also going to do the same thing with my y values here. So 1/4, 1, 4, and 16. So now we're going to apply these transformations. The first one and only one that we're going to apply at least in this example to my x value is going to be my horizontal shift to the right 8. So if I'm going to the right 8, that means I will be adding 8 to every single one of these values here. So plus 8, plus 8, plus 8, and plus 8. So my new x values, which are going to be the ones that I'm going to be plotting on my graph, are going to be 7, 8, 9, and 10. So again, I'm just now applying my horizontal shift to the right 8 to my x values, and only to my x values because horizontal shifts affect my x values. I'm going to do the same thing now with my y values, except this time it's going to be my reflection over my x-axis and my vertical shift up 7. So a reflection over the x-axis will turn my y values negative. So it's going to be negative, and I'm going to go up 7, so I'm going to add 7. So if I now go ahead and apply that, I'll have a negative 1/4, negative 1, negative 4, and negative 16. And then I will be adding 7 to my values here. So this will give me a positive 6 and 6.75, or 6 3/4. This will give me 6. This will give me 3. And finally, I will get negative 9. So I'm going to go ahead and plot these points here. So at 7, 10, 9, 8, 7, I will be going up 6.75, which will be about here. At 8, I'll be going to 6. At 9, I'll be at 3, 1, 2, 3. And at 10, I'll be at negative 9. So this one will be going downwards or decreasing. And if we want to connect these points at the start, or what we have here, it'll look something like this. Now, going to the left, as we approach negative infinity over here, it will get close to our asymptote, but like all asymptotes, it will never actually touch it, so it'll look something like this. So this is what negative 4 to the power of x minus 8 plus 7 would look like graphically. And now let's go ahead and just write our domain in my range. My domain for my exponential function will be all real numbers, so negative infinity to infinity. It'll go on left, it'll go on right forever. Now my range, though, it approaches from negative infinity, but it has an asymptote at 7, so it will approach from negative infinity to 7 with a parenthesis, because again, it will never touch 7. So this is an example of graphing exponential functions. There will be 2 more videos, one on question number 2 and one on question number 3 addressing this, but this is just the overall walkthrough of how we would solve one of these questions. And again, look out for part 2, where we'll be doing logarithmic functions.